My name's Mark Dawes. This is a Year 8 class, and this is the first lesson on looking at the bounds of intervals and the idea that measurements are not entirely accurate. What we're going to do now is you're going to use some non-standard units of measurement. I'm going to want you to choose something to measure. You could measure the length of the classroom. You could measure the width of the classroom. You could mention the length of the corridor.
So we'll say 10, because that's, you know, the kind of average.
Great. We've got some pupils who've, using a bit of creativity, they've decided they want to measure the corridor. They've decided they want to use a member of the class to do that with. So they're enjoying moving their friend along the corridor to find out how long it is. It's something that's great fun to do. It's something that I tend to do when I've built up a positive relationship with a class, because I want them to be able to go out. I want them to be able to go out into the corridor. I want them to be able to move around the classroom. And clearly, I need to trust them that they'll be able to do that.
31, 32, 33.
Now, the next step is going to be to look at their measurements and to see that they can only say to the nearest whatever they've used. So they can only say to the nearest pen or to the nearest pencil case or to the nearest shoe what their measurement is, and we can use that to develop the idea that when we're measuring in metres or centimetres or millimetres, we're still only measuring to the nearest whatever it is they're measuring with. We've then got the length of the corridor to the double doors. That was 63 pencil cases. And the length of the whole corridor is 41.5 bends. Now, I want to know which of these are less useful, which of these are less appropriate. Start us off, Rota.
Some of the units that they use are more precise than others. Like, one used pencil cases to measure the corridor, but another person used, well, a person. And since the pencil cases are smaller, they're going to be, it'd be more precise and easier to get an image of how big it is.
Now, that's a lovely idea, and that's a really, really important one. If you measure the corridor in pencil cases, it's more accurate than measuring it in Myers or measuring it in Maskell's. One of the things I'm particularly interested in are the numbers that we've been given. 10 pencil cases for the height of the door, 16.5, 19.75, 41.5. I'm interested in some of the numbers that we've been given there. Krishna.
For the people being measured, how they've put like a half and a 0.75 of a Ben or a Myers or a Maskell, it's a bit inconvenient because they don't obviously have like a ruler or a valid measurement, so they can't really tell, and also because it's a height, it would be continuous data, so you can't measure exactly either.
Now, this is one of the really big, important things from this lesson. 16.5 looks suspiciously over-accurate here. So, what would be a more appropriate answer for you to give rather than 16.5?
Because we said 0.5, then you round up the 5, so maybe 17.
Can anyone comment on any of the other measurements that we've got here? We know that the display board is 10 of a particular shoe long, so what do we know for certain?
Well, we don't know the exact measurements, though, because obviously we're doing it to the nearest size 5 shoe, because, you know, we can't have 10.38 of a shoe,
right,
because we just would not be able to do it to that precisely, so we don't actually know anything about the exact measurement.
OK, now, somebody else who wasn't part of that group, what do we know about the length of the board in size 5 shoes?
The smallest it could be is 9.5.
So the smallest it could be is 9.5. What's the absolute biggest that it could be?
The biggest it could be would be 10.4.
Any comments on that?
I disagree, because I think it would be 10.49 if it would just be recurring, obviously.
So we've got a problem in that it might be bigger than 10.4, but still smaller than 10.5. Great. Now, what do we know for certain about the length of the corridor if we're told it's 63 pencil cases long?
It could be from 62.5 to 63.49.
So we know it's in between two particular numbers. And that's a really, really key idea, that when we're told a measurement, we don't know that it's exactly that, but it's implicitly telling us it's in between two measurements. It's a really lovely way to tackle the big misconception that if we say that something is 4 metres long, we don't mean that it is down to the nearest millimetre, the nearest micron, the nearest molecule. It isn't exactly 4 metres long. We can't say that. And this is a way to sort of introduce that as an idea. But it is great fun. The pupils really do enjoy it.